Hi everybody, Mary here, and welcome to Chapter 4. We are in our 5th week of online physics. How's it going? Hopefully you're having some fun. Hopefully you're enjoying the online labs. I think the labs are the best part of physics, so I'm so excited that you get this lab experience at home. This week you are about to embark on Newton's laws, and Newton's laws are considered by many people the heart of physics. They are the big important parts of the primary understanding rules of the universe. They are a big deal. And you've learned so much. We have gone through how to solve problems, how to do trig, how to write down problems, significant figures. You know how to graph things now. You have a lot of basic knowledge and tools, so now we can rock and roll. Now we can go through a lot of really interesting physics information. So as we enter forces and Newton and all of the things we're going to do, this next chapter is a big one. This is going to be another one of these 2-weekers that you're going to be on for a while. So I want you to pace yourself. I'm going to kind of give you some hints of how far you should get at the end of the first week. We've got 2 labs that you're going to be doing. And so this is a big, fun, and very different chapter. So if you didn't love kinematics and straight line motion, that's okay. Physics has a tendency to change its personality from one topic to another to another. And there are some parts of it I love more than others, and I kind of really love these forces. So I hope you do too. Let's take a look at our schedule. And we are to the point where we are on weeks 5 and 6. We're going to be on chapter 4. In your OpenStax textbook, it's really chapters 4 and 5. I just call it chapter 4 because of the fact that it's simpler on me to call it chapter 4. And you'll notice in the first week of this 2-week block, the only thing that you have due is the friction lab. But please spread the learning out over 2 weeks. If you try and do all the learning in 1 week, it's going to be too much. There's a lot here. There's a lot of meat here. In the second week, the end of that second week, you're going to have a second lab due, plus a study guide, homework, a quiz, and a big problems test. Now, the problems test and quiz are just going to be over chapter 4, and I did that particularly or specifically because of the fact that this is a big and really important topic. So let's take a look at Canvas and what we've got going. So we're going to start with Introduction to Dynamics Forces Newton. Of course, we've got a study guide. We're going to talk about inertia, mass, weight, Newton's 3 laws. We're going to have homework problems and friction, and then the friction lab. Now, I'm going through just the modules this way instead of clicking through things because this, I think, is a nice overview of how far you should get by the end of the first week. There is learning and videos in 4.1, 4.3, 4.4, and if you get through all of this up and including the friction lab, then you will be in good shape. That is about half of it. The mathematics for the first half is not too bad, and then you're going to be in decent shape for doing the second half, the second week. That friction lab is kind of a fun one. The math for this is not terribly complicated. What you're going to do in this friction lab is you are going to be dragging things around with a little beast called a spring scale. So you have a spring scale that came in your kit. Spring scales are used to measure forces, and you need a box of some sort. Something that's not going to mar a surface. You're going to put a big rubber band around it, and you're going to need weights. And you're going to have to be a little bit creative as you're finding out doing labs at home. It's going to involve a little creativity and a little problem solving. So options of what you can use for that first box, some of the things I found around my home is food boxes like macaroni and cheese or something like that. This happens to be the bottom of a little trinket box, a little jewelry kind of box that's made out of wood. This is a cardboard box that I think I got a present in. Each one of them has a rubber band around it. You only need one, but I wanted to show you a variety of different things that would work. They all have to be under 500 grams of mass because that's the limit of your little electronic balance. And then you're going to need weights. Each one of the weights have to be under 500 grams of mass. And to get more mass, you can stack them. And then to find the total mass, you just add however many of these objects you're going to put on your box that you're going to slide around. So you're going to use this little electronic balance lots and lots in this first friction lab. I recommend the mac and cheese box because I think a lot of people have mac and cheese, but not everybody. When you're sliding things around with your Newton spring scale, please slide them horizontally, not at an angle, because you don't want just the you want to have all of the applied force to be horizontal, parallel to that surface. If you pull at an angle, you are only going to read on the spring scale in a component of that force vector. And so this is good and this is bad. And so that's why I have a couple pictures of the right way and the wrong way to do it. As I mentioned, this lab is not terribly complicated mathematically, but it will give you some practice doing some of the math and drawing some force vectors. So this is the first of the 2 labs for this week, or excuse me, this module. The second lab is going to involve an inclined plane. Now, the inclined plane lab, I think I have to change the name of it. I've got it down here as Newton's second law lab, but it's actually an inclined plane lab. And it does involve Newton's second law, so I guess both names are accurate. What you're going to use is the same little box with weights, but you are going to drag it on that white bit of cardboard, kind of a plasticky board stuff that you got in your lab kit. You're going to make an inclined plane out of that. And so you're going to begin the lab by finding the coefficient of friction on that surface. You can use the same box that you used in the friction lab, or you can use something else. But after you have that done, you're going to set up that piece of cardboard as an incline. It's a little bit rickety, and so I've discovered you can't set it up so that the end is propped up on a set of books. You have to kind of set it up near the middle and then use another support. I use the little plastic dish from our kit to help support it. And I also found that I needed to add a little bit of clay to help support this whole setup. And I also put a few little globs of clay here to make sure that it doesn't slide every time I slid my macaroni and cheese box down the incline. You don't want this ramp to change angle, so you want to keep that angle the same. And so a couple little wads of clay are going to help do that. You're going to be timing how long it takes the box to slide down there. And then when you're all done, you're going to do a big, massive, whopping calculation of forces on an inclined plane. You're going to have a big calculation you're going to show me right there. But by the time you get to that point in the chapter, you're going to know how to do that. So that's going to be, I think, not too bad at all. So at the end of the chapter, we are going to have a concepts quiz, a problems test. Everything is going to be due at the last day of the chapter, except for the friction lab, which is due 1 week early. Have fun. Forces are a lot of fun. And if you like a change of pace, physics is for you, because this chapter is different than last chapter. As always, holler, ask if you have some questions as you go about things, and enjoy your week. We'll talk to you soon. Alrighty, bye-bye.